Hi everyone, welcome to Unit 5, which is Chapter 6 out of your textbook, and it is about conic sections. So you might be asking, what is a conic section? And a conic section is pretty much just a path that something can take, an object can take, and it comes from the intersection of a plane, just a flat surface, and a right circular cone. So depending on how that plane is intersecting the circular cone, you could get a circle. So your plane would be horizontally here. You could get something called an ellipse if your plane is diagonal. If your plane just intersects one part of this cone, you can get a parabola. Or if it kind of comes down vertically here, you can get two parabolas, and both parabolas together are called a hyperbola. In this unit, we are going to be studying circles, ellipses, and hyperbolas. So here's all the items that you're going to be expected to be able to do in this unit. So I'm not going to read through these, but make sure you put your name on your packet. So this is going to be a fast unit. It's 3 days of notes, 1 day on circles, 1 day on ellipses, and the third day on hyperbolas. And then we're going to have a review day where you're determining which shape it is. All right, so here's some homework problems to do out of the book. So that would be a good place to go for additional practice. Okay, so topic 1 is all about circles and equations of circles. If you want to reference it, it's section 6.1 of your textbook. So first of all, the definition of a circle. A circle is a set of points in a plane equal distant from a fixed point called the center. So you're starting with a fixed point, the center. You're starting with a certain length. So imagine if this was a pin and you had a string attached to it. It's the path that that string would make if you went all the way around. Or imagine a dog at the end of a leash. The biggest area he could run in here is that outer circle. So that's how you get a circle. So there are equations for circles. So there's 2 of them. It depends on where your center is. So this is the equation of a circle in standard form. X squared plus y squared equals r squared. Now you might be looking at that saying, like, that looks like the Pythagorean theorem. That's exactly where it comes from, is the Pythagorean theorem. Because if you were to draw in a right triangle, this length here is your x value. This length here is your y value, and we're going to call that's our radius of the circle. So it's the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So it just comes from the Pythagorean theorem. So it's this formula if your center is 0, 0, and r is your radius. So it turns into this form if our center is translated. So if your center is the point HK, then it just becomes the same formula. The x's are still being squared, but we are translating it. And the y coordinates are still being squared, but you're translating it. Notice there's an addition sign here, and it equals your radius squared. All right, so notice there's subtraction signs in the formula. So when you pull your center out, it's the different signs. And your radius is always the square root of whatever number is here in your formula. All right, so circles are very easy to graph. So number 1 says, find the equation of a circle with a radius of 6 and a center of -3, 4. Well, we can just go ahead and substitute these values right into these equations. So it says x minus h. H is -3, so x minus -3 turns out to look like x plus 3, and that quantity is squared, plus y minus k. K is the number 4, so y minus 4, quantity squared, is going to equal your radius squared. 6 squared is 36. So there you go. So when you take your center and you put it in, it looks like the signs are changing. If you had the equation and you pull your center out, it looks like the signs are changing. The reason is that there are always subtraction signs in the formula. This number, square root, is your radius. All right, so you are going to need to know both these equations. So that's something you should highlight. And it's also important to know that the circle is the set of points that's equidistant from a fixed point. We only have one fixed point. That becomes a little important later. Now to graph a circle, it's also very easy. It's easy if your grid lines show up and you can clearly see where the center of your graph paper is. Unfortunately, my axes are the same color as the graph paper, so I'm just going to kind of make them a little darker so my brain knows where the origin is. All right, so you're going to start by plotting your center. -3, +4, and I apologize, this graph paper is teeny tiny. So that's your center. Now remember, your radius is 6. There are 4 points, 4 exact points on every circle. You can go to the right 6, 1, 2, 3, 4, 5, 6. You can go to the left of your center 6, 1, 2, 3, 4, 5, 6. You can go up 6, 1, 2, 3, 4, 5, 6, and you can go down 6 from the center, 1, 2, 3, 4, 5, 6. So you have to get pretty good at connecting these, or actually grab a compass if you want to draw a gorgeous circle like that. All right, now let's state the domain and the range. Domain, how far to the left does this go? Well, the farthest point to the left is this value right here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And it can equal it. There's a value there at -9. And then this point here is the value 1, 2, 3. It's actually your x number plus 6 and your x value minus 6. Oh, I'm sorry. Yeah. So you're going 6 to the right and 6 to the left. All right, your range. How low does this graph go? The lowest value is right here, so that is at -2. And the highest value it goes is all the way up here, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, it is your center plus 6 and minus 6. That's the y value. So these are very easy to do, very easy to graph. All right, let's check out 2. For each of the following equations, graph the circle by hand and state the domain and range of the relation. Same thing, now I'm giving you the actual equation of the circle. So from this, you need to pull out your center, which in this form, your center is 0, 0, and your radius is the square root of 9. So again, you're going to have to go and plot this. I'm making my axes a little bit thicker so I can actually see them. Sorry about that. All right, center is 0, 0. Radius is 3, so you're going to go to the right 3. You're going to go up 3, to the left 3, and down 3 from your center. And again, you could grab a compass. I've been doing this a long time, so they're pretty good. Domain, how far to the left? The farthest we're going is -3. How far to the right is +3. And mine's off a little bit. I'm just going to make those dots bigger. And your range, the lowest it goes is -3, and the highest it goes is +3. Okay? For B, I'm going to pull my center out, and remember, it's always going to look like the opposite. So I'm going to take a +2 and a -5, and my radius is the square root of 25. So I know my radius is 5. So I'm going to just thicken up that axis a little bit so I can see it. Okay, center is 2, -5, 1, 2, 3, 4, 5. Your radius is 5, so you can go up, down, right, left, 5. Doesn't matter what order. You're just counting. Connect them all in a nice circular round fashion. It takes a lot of practice to be able to draw a very nice circle by hand. All right, domain, how far to the left? -3. How far to the right? 1, 2, 3, 4, 5, 6, 7. And again, it is your x value that you're subtracting 5 and you're adding 5. Oops, that's not right. Bracket, because we actually have a value at 7. And the range, the lowest this goes is 1, 2, 3, 4, 5, 7, 8, 9, 10, -10. And the highest is 0. And again, if you added 5 and subtracted 5 from the y number, that's another way to get those. Okay, so I would like you now to do problem 3 ABCD all by yourselves. So you go ahead, stop the video, and do all the problems on the next page all by yourself. Check the answer on School Tool on the answer key. Okay, moving on. I'm on page 5. If we have to write the equation of a circle, again, you need to know your formula. So as long as you know your formulas, this is simple. You just are putting the information into your formula. So I'm going to do problem 2 with you. If the center is 0, 7, I know it's going to be x squared plus parentheses y minus 7 squared, and it's going to equal the radius squared. So if your radius is square root of 7, when you square it, you get 7. So that's it. I'm just substituting items into x minus h squared plus y minus k squared equals r squared. That's my form for the equation of a circle. So it's very easy. All right, so you can go ahead and do 1, 3, and 4. Be careful. I'm giving you the diameter. Trick question. And then I'm going to do 5 with you. So we have the center. So I know this is a circle. So I'm going to go ahead and substitute these values into my equation. Now I need the radius. But if my center is at the point -4, -6, and it passes through the point 3, 2, my circle looks something like this. Now I need this radius. Remember, I need that length, that radius. And you can use your Pythagorean theorem again to figure that out, or the distance formula. The distance formula, if you remember from geometry, it comes from the Pythagorean theorem. So if my center is the point -4, -6, and it's passing through the point 3, 2, we need this vertical distance. So you are subtracting your x-coordinates. That's all you're doing. So if you're at -4 and you went over to +3, that length is 7 units. And if for the y value, if we were at -6 and now we're at +2, that is a distance of 8. So you are just plugging those numbers into the Pythagorean theorem. Instead of c squared, I'm going to call it r squared. So you have 49 plus 64 equals the radius squared. That's the value. 113 equals your radius squared. Now, remember, radius squared is what I need in my formula. I mean, if you wanted to, your radius is going to be square root of 113, but to put it into the formula, we square it. All right, so now I would like you to stop the video and finish all the problems on this page, and then come back when you're done. All right, moving on. How do we know when we have a circle? If you complete the square, you can take it from general form. This is general form, and we can change it to standard form for some number m. And remember, this is our equation of a circle, and m is your radius. So we're going to actually have a circle or not, depending on the value of m. And well, this number has been squared, so the radius is the square root of that. So if that value over here is greater than 0, you will have a circle. It means you actually have a radius. Your radius is a positive number, and it'll be the square root of that, just like we were doing before. If this equals 0, it's saying the radius is 0. That you can't make a circle that has a radius of 0. It would only be a point. So that does not make a circle. And if this number is negative, that means you have a negative radius, which doesn't make any sense. So that would not make a circle. So the general form of a circle actually looks like this. ax squared plus by squared plus cx plus dy plus e equals 0. But what makes this a circle is the value a equals the value b. Now I'm almost out of time on this this section of the video, so I'm going to stop here and pick up again on part 2 of the video. Bye!